Very good to see you all. And yeah, as was announced, this is one of the few talks that is done in English. I hope that is fine. I will try to speak as clear as possible, because also with the large room, things are maybe easy to miss out on. The title is Beyond Design Principles and Patterns. And yeah, this is a rewrite of an older talk where I try to think about yeah, really what is beyond design principles and patterns. But yeah, while doing this, while preparing this, I was more like, yeah, maybe we should go before design principles and patterns and try to figure out what really is the basics of object-oriented programming and how to do that right. Because yeah, as you may know, this nice list of design patterns, I don't know if you get a list like this taught at school or something, or you just learn it from the original book, right? Oh, I see some noddings there. That's great. So you learn this stuff, but then in practice it turns out that many people actually use these patterns in a different way than they are in the book. So then it's pretty confusing. Like you read the book and you're like, oh, I'm going to apply like a chain of responsibility, for example. And then you look up the pattern in the book and it's completely different from what you're actually after. So there is sort of like simplified versions of these patterns that are more useful maybe even than the ones that are in the book. So it's interesting material for studying, but then it also requires a bit of reflection. Like, can I use this really in my project? Then there is lots of other stuff, like design principles, maybe the solid principles you've heard of. There are package design principles, and lots of other catalogs of patterns. And you have the same issue with these. Like, you can study them, you can learn them, you can memorize them, but then how to apply this stuff? That's always the hardest part, right? Yeah. I think there's something wrong in this respect with education, where we focus on all this stuff, like getting the words right, getting the whole catalog into our heads. Maybe also even do job interviews saying, can you tell me the solid principles, right? But again, telling them is not quite enough. In fact, I would say you can basically forget all that stuff. Like, this is maybe a bit controversial, but as long as you get the basics right, if you think about objects, about their design, and to make it all really simple, but also really strict at the same time, you can do a lot of great work without even thinking about what kind of design pattern from the Gang of Four book you should know, or you should apply. So yeah, what is back to basics? Yeah, I think this is about object design, but yeah, in a sense, this may also come from experience. Like you just collect some of the useful rules while designing your objects, and it's like you design them in several ways, and then you try to think of like, how can I make this into a rule? How can I turn this into a rule and talk about it with people? Because that's what you want to do with a team. You want to say in a code review, for example, maybe you should look for a different pattern to apply here or a different principle to apply here. That's why it's also so very useful to have all these nice names, and you could say like, oh, you should use dependency inversion here, even though it's a bit of a complex term maybe, or hard to remember, or hard to get right even. Yeah, so I think it's useful to get back to the basics and to think about where do we come from, where did we come from as developers. And in fact, we have to go really back to basics to think about basically what is civilization, right? How are we evolved as human beings? Well, we do two interesting things. We are describing things that are happening, something like a history, or we are describing agreements amongst each other, but we're also counting things or measuring things. And we have these primitive type values, hence the primitive, right? So we have strings of characters. Basically, together these will become text. And we have the numbers. Yeah, and we have different names, of course, for this, like integers and floats. And maybe there are different other types of numbers that your language, which I guess must be PHP, supports. And then if you go back to these basics, you have these primitive type values. And you start sort of combining them into more interesting structures. And these will be known as objects. And the cool thing about objects is, as soon as you start combining values into these objects, you can also basically take objects and combine them again together, building up an entire object graph. If you think about like today's programs that we make, it's basically one large object graph, and the execution goes through this graph and ends at some point. Maybe the next time it goes through another branch of the tree, but it's still the same thing. It's an object graph that we traverse through, and finally this gives us some interesting answer, or it does something that is useful for us programmers, the ones who were thinking about the application. The thing is that you can create these objects, and you can combine anything like primitive type values or objects. And if you want to use objects, you will use these classes. But object-oriented programming, and in fact creating good objects, is very far from just using the class keyword in your language, right? Or using the interface keyword. In fact, using either of these is not better than using primitive type values only. So if you want to do it right, you have to think about, what is good class design? What is a good object design? The first thing you can do with an object is that you introduce meaning. And this is pretty basic, but it's good to have it on screen. The class name will be the type of the value, and it will be a more interesting, more specific name than a string or integer, for example. So you're introducing like a wrapping object, which also comes with a bit of meaning. And this is, I think, this will make it clear just visually. There is every string in the world, every possible string, but only some of them would count as an email address, right? There is a certain format to this type of string. And this tells you that it's an email address, or it can be used as an email address. What you can do with an object is wrap this string that is supposed to be an email address and sort of protect that it is indeed an email address and that you can use it everywhere in the application as such. So this comes with some meaning, with some knowledge, and we will go into that, of course. As another example, there is every float you can describe in your system. And there is the floats that could be used to describe a latitude, like a geographical coordinate on this planet. I mean, not every float will be useful for that, right? So you're limiting the amount of possibilities there. So you say it should be this value within this certain range, this certain type, but you also give it a name. I think that's the most useful thing about objects, right? You can give it a name. Very, very handy. In fact, I always teach this as a rule for designing classes or objects. It's like if you're passing around a string, for example, as a method argument, you have to think like, could this indeed be any string in the world, or do I have certain expectations about the string? Do I want this to look like something, or to be useful in some way? If there is any rule that comes to mind, like it should not be an empty string, for example, that's a very, very common one, or maybe there is a regular expression pattern that you wanted to match. You know, this is the kind of stuff that requires you actually to introduce a more specific type. Basically create an object for this very simple primitive type value. And really the same goes for this integer thing, or just as this example. Not every integer in the world could be an age, right? Because it starts with 0, and there is maybe some upper limit where we don't consider that reasonable anymore. So that's why, again, it would be smart to limit the numbers there so that no part of your system accidentally uses an age that, well, doesn't make sense, right? So the first thing you can do is limit the scope of a value. You could say it should look like this, it should have this pattern, it should be usable in this way. But objects can also be used, like I said, to combine different values, like latitude and longitude. These belong together. They are you cannot see them as separate things, basically. The same for x and y. Usually it's like there is a coordinate, so it's x and y. The same really for amount and currency. There is a monetary amount, but if I say I've got 100 in my pocket, like that's useless. You need to know what is the actual currency of that in order to know if it's worth anything. And this is the more general approach here, like you have a number and its sort of unit, the unit of measurement that you use. So it could also be the number and kilometers, so to speak. The interesting thing is about objects, they have this property of keeping data together. And yeah, in this sense, what is together will start to belong together very quickly. It's like arrays, they have keys and values, right? This is you cannot see them as separate things. But what belongs together also gets together. And I think that is a very useful property for objects, or a useful way in which you can use objects is to wrap values in them and then wait until it starts attracting behavior. Like there is usually lots of information, lots of knowledge about a value in the whole code base. But now with an object, you can basically combine that stuff into one single class and have the knowledge at the same place. This kind of like behavior attracting, well, sort of property of objects. That's a very interesting one and a very useful one. So that's why I keep suggesting, like, introduce more objects for your values. Even if you feel like this is too simple, it doesn't need a specific class or object. Yeah, it can still be useful because it starts attracting related behavior. Yeah, this is sort of Java examples, I think. I hope that's okay at a PHP conference. As you can see, this is where you can combine interesting behavior. Like map could have get and set. These are inseparable. You should not be able to use them on a different thing. Like they belong on the same class. Array push and pop. It's really part of the same thing. Yeah, and so these objects, they start to attract behavior, and the values that they wrap could be called state. And that's why people always tell you about objects, like they should be having state and behavior. That's sort of the idea behind an object. So now you know where this comes from. If you translate this to code, you could say that the state is just the data that is inside of the object. Yeah, usually it's inside the properties, right? The behavior is all of the methods that it exposes, the ways that you can use it, but also the ways in which you can construct it, the things that you can learn from it, the things, the ways in which it can change. This is all behavior. What I find very interesting, if you look at your code base, there will be classes that show different interesting aspects in terms of state and behavior. Like you could compare the number of properties with the number of methods. And in that sense, you could say that some classes or some objects will have more behavior than others compared to their state. And in fact, you could say that objects need a place on this diagram, where this is about sort of relative state versus behavior. Services, at the lower right, they need to be stateless. There should be nothing stateful inside of them that would make their behavior different. Like we should not be able to modify their state in order to change their behavior. They should always do the same thing. Then at the top right, we have entities, which is a very interesting type of object, which has state, but also a lot of behavior. At least that's what we strive for. In the middle, it's more or less the same thing, but it's less of both. So there's less state, less behavior on value objects, but it's still sort of an equal amount. But on the top left, there is some interesting stuff going on there, because primitive values are really just state. There's nothing behaviorish about them. You can't really do anything or do much with them on their own. So you need external functions or operators to manipulate them. And in a sense, it's the same for anemic domain objects. If you don't know the term, it could be interesting to look that up, because I'm sure there are lots of objects in this world that are still anemic in this sense. So you could even leave out domain there, because this is about objects that don't protect their own state in any way, so they just accept any data that comes in. Yeah, it will be just interesting to take a look at your project and compare like different types of objects, and are they on the right place in this diagram. Something that can also improve for all objects, basically, like not just have the right amount of state versus the right amount of behavior, is to make sure that every object can only exist in a completely consistent, coherent state. That's something that is not the case in many projects, I would say. Just take a look at objects that can be constructed without any data into them, right? Just an empty object. Like, is that useful? Is it consistent? Is it in any way coherent? Or will that give you some surprises? Yes, it will. So that's a good rule to follow in general. Like, make sure that all the objects in your application can be used and can be used in a way that doesn't come with surprises. So how do you do this? Well, at first, at construction time, you need to make sure that you provide all the right data. Maybe there is a minimum amount of data that is required for the constructed object to be even working correctly in any way, or to be even useful. For some of the other objects, like services, you would need to inject all of the dependencies at once. So don't create like half-life services where there's something missing, or maybe something has been provided, maybe not, right? If you need it, you need to provide it. There's no such thing as an optional dependency, right? It's every dependency is a required one. So that's why I'm strongly against using setter injection. Like if you have a service, don't add more dependencies along the way. So just make sure that everything is right there in the constructor, right? And also no setter parties for the main objects. It's like we don't want to have an instantiation and then set, until at some point we, well, think that the object is sort of useful or has become useful, right? Because we don't know, in fact. We can make a mistake with that, we can forget a line, and the object will start behaving in very unpredictable ways. But the same goes for a modification time. Like, we have to provide the right data when constructing, but also definitely when we're calling a method on it that's making a change. So we also need to provide the right data there. And I'm saying right data, where this is a bit of an abstract term, of course. I'm being a bit unspecific about it. So what is the right data? Well, first of all, it should be valid data. It should have the correct types. It should look correct. And this is where you could use, again, objects to sort of wrap primitive values and make sure that they are already like trustworthy, they are already valid. But it should also be meaningful. Like, you should not be able to, like in the case of the age, you should not be able to pass a minus or a negative age to a method, right? So again, that's where objects are very useful. But still, it makes sense to, for instance, check that a list has at least one item. That's something you want to check before you continue, or else your system might break. And that's, it's both for the callers who need to provide the data, as well as for the class that needs to check that this right data has indeed been provided. So it has to be valid, as well as meaningful in the context of the method. One thing that people often forget is not just to validate the incoming data, but also making sure that the object, after processing the request for change, doesn't end up in a weird state. So as an example, if you cancel an order, but in fact it was already shipped, then yeah, that doesn't make sense. So you should throw an exception there and say that this is not an allowed state transition. I think the state machine, or as you may know it as the workflow, is really on the rise again. We should be thinking about what kind of phases in the life of an object can really exist. What is a meaningful transition from one phase to the next? With objects, we can be very specific about that. Like for life, it's much more difficult, right? We have different phases, and we end up in weird phases sometimes. But for objects, yes, definitely make sure that it is impossible to make it end up at the wrong place. When writing any of these methods at all, there's basically a simple template you can follow for writing them. And this is the place, I think, where many legacy projects can basically improve a lot. Like legacy, who's not working on legacy, right? This is for everyone. But you will find some of these methods that are very, very long. And the mistakes they make is that somewhere halfway the method, something gets checked, and then somehow, yeah, this may break the whole flow, right? So we end up with a method that is practically useless at that point. because we have been doing so much stuff before we realized that we couldn't continue like this, right? So that's why it's always good advice to fail early, to in fact do even some precondition checks, like if you get primitive type values as arguments, then make sure you check some things about them at least, to make sure that they are useful, they are meaningful. And then if there is some condition based on which this could not work, you can be sure about that it can't work, make sure that you throw an exception there. You fail, you jump out of this method very quickly. The happy path itself should not be hidden somewhere inside if, of course. It should be right there on the zero indent, like there's no tabs there. It's just the main flow of the method. Then before you return, you might want to check some things about the values that you are returning, because maybe you're doing it wrong and you're giving something back that doesn't even follow the contract of your interface. So that's something to be worried about for a bit, but not for every method. Like most times, it will just be returning the value and no further checks. Then when we're talking about these methods, there is the template for methods, like fail early and then the happy path and return. But there is also some other very interesting principle, thing that we should definitely apply to all of our methods. It's that every method should either be a command method or a query method. This is known as CQS, command query separation. And it's just a thing that will make your code much clearer, much brighter, and much easier to use as well. So if you look at these methods, a command method can be recognized like in the sense that it's a void method, so it has no return type. This means that it's going to do something, but it's not going to tell you something about a result or anything. It's just going to do it, and if somehow it doesn't work, then it throws an exception. So that's the way it will talk back to you. This kind of method may have all kinds of side effects, like maybe manipulating the database or file system, or making a network call, which can fail for all kinds of reasons, but at least it's going to make a change at some point. So calling it again will usually behave differently. It will not make the same change again. It will maybe make another change, or maybe fail because the change is impossible anymore. It's not possible anymore. And then there is the query method, which is a completely different thing. But I must say that many code out there is really mixed in this sense. So it combines command and query, hence the need for such a principle. So the query method returns something, but doesn't actually change anything, at least not in an observable way. So we should not be able to detect a change about the system that has happened while we were calling a query method. This gives it the interesting opportunity to call this method again and again without any trouble. So we can just call this, and we will always get an answer. So CQS principle tells you that once you know what these command and query methods are, that you should always that every method should be either of these two, like either a command or a query, and that so asking for information, that's the most important thing, doesn't change the state of the system, right? That's a very, very important thing. And I think maybe while you're talking or thinking about it, it's very clear, but there's so much code out there that mixes the two. So just a way to improve your project on Monday. Something that I'm a very big fan of is also in terms of methods and return types. If you're talking about these query methods, they should be very specific about their return types and not return different types of values. So if you're expecting a specific type of thing back, then you should either return that or throw an exception. And in the case of a list of things, you should, like this is an example of the first case where you want to return something specific. If you can't return that, throw an exception. Just say it's impossible, I can't do it. Otherwise, you would return the object. I think the traditional alternative here is to return null or return false, which is very bad for the caller. Like it has to check if something is either this object type or null, or so it's smart to always make return a specific thing. And the same for lists. If you can't find anything that matches a certain criteria, don't return null or throw an exception for that. Make sure that it's a list, and you can use this list if it's empty or if it's full. Shouldn't make any difference. At the failure point, throw exceptions, like, again, don't return false or null in that case. You just make sure that, yes, thank you, that it's clear that something went wrong, and you just really, you scream about that. And this is something where I've seen lots of different approaches, where some people will say, like, yeah, you should be defensively programming, so you should worry about everything that could go wrong and then try to recover from that. I am more of an offensive programmer in this sense, where I'm trying to throw as many exceptions as possible, because in practice, these exceptions won't be triggered. It's not like your application server will be down all the time. It will just be very useful to throw these exceptions and keep a look at the logs, of course, when these occur, because they will often, or in fact always, indicate something that's wrong about the system, something that's wrong about your design, or maybe you made a programming mistake. So in fact, I would rather know now and very loudly than just wait for some weird data issue in the database, or some weird customer complaint that is hard to debug. So yeah, throw exceptions and be very loud about them. The same for static analysis tools. Like, in fact, you should have gone to the other room and listened to Damien talk about that. But I think static analysis is a way of screaming as well, screaming about things that are wrong about your code. For example, if you run datetime create from format, PHP stan in this case will tell you that the return type of this method is bool or datetime, right? It's a Boolean value, it's false, or a datetime instance. It's very interesting to know, because one day it may start returning false while the rest of your code is using it as if it was a datetime object. So you will get this fatal error method call on null, for example. Very awful experience. With PHP stan, I would also set it to level max. Say, scream as loud as you can about anything that you think will go wrong or could go wrong at runtime. And in fact, once you see these kinds of things, once PHP stan has opened your eyes, you can start dealing with it. So now you can wrap even native functions or functions from libraries that don't follow this advice. You can wrap it in something that definitely gives you a datetime immutable or throws an exception. So that's a very useful trick. In fact, I didn't see it for datetime immutable yet, but there is a safe PHP library in the making which does this kind of thing, in fact. So whenever you call a native PHP function which would be able to return false when it's actually a failure, then it replaces this with a function that does throw an exception. So that's pretty cool. They use generated code, which makes it reliable enough to just immediately start using this stuff. Okay, then, well, we should reconsider the whole state versus behavior thing. Like we saw the diagram with the state versus behavior. We also know that objects do have state and behavior, but this is something else than having data and implementation details, right? So the object has state and behavior, but it hides its internal data structures, but also its implementation details. So you cannot know, or you shouldn't know as the user of the object, how things are done inside of the object. And this leads to my advice here is to expose more behavior, less state. So make sure that your object is not about keeping data and releasing it again. It should be about doing something useful or giving meaningful answers itself. And one trick that I can show you about this is or trick, it's not really a fast thing to do, but it's something that helps when writing tests for objects. If you write these unit tests for them, yeah, you should start treating these objects as black boxes, basically. So you have to make sure that your test isn't really worried about the details that are going on inside of the class or inside of the object. So it shouldn't worry about exact types of data that is being used, which data does it carry around, how exactly does this algorithm work. You should just look at the outcome, like how can I use this object, and will this give me what I need. One thing that is, I think is very interesting is about the, but maybe I'm the only one who finds it interesting, but anyway, we'll see, is that we usually start with testing classes by creating a constructor and putting data into the object, and then seeing if we can get the data back out, right? This is a very standard approach. In fact, this is what it could be like. It could be the unit test saying, this object can be constructed, right? So we have a money object with a currency, and we put some data into it, and then we assert that the data that we get out of it is still the same as that we, thank you, as that we got that we put into it, right? This is not really about behavior. This isn't telling us anything useful about does this object offer anything useful in terms of behaviors, something that I can use in my project, something that is that shows a sign of some knowledge that is hidden inside of this object. If we wait, if we don't test the constructor and the getters, we could do something like this. So we wait until we find the first interesting behavior, like currency conversion. That's an interesting behavior when it's about money. And then we create money objects. Again, we don't test for getters, but we do something with an exchange rate, which is a different object. And somehow, when we convert it based on this exchange rate, we can compare the converted money object with one that we construct based on what we expect it to be, right? It's an interesting, it's a little bit of a difference, but I find this very useful. It might be that the convert function actually still needs the getters, but you will add them only when someone else needs them. So this is the idea. Only add a getter if something other than a test needs it. Could be like I called it a guiding experiment, so that you could try it at home or at work, and then see how that works for you. How you can even remove lots of getters from an object, because it's going to be useful. It's going to be doing useful things anyway, also without the getters. All right. Another thing, when you're looking at behavior and objects, I think it's a good idea to, once you go into the code base and need to make a change to something, to the behavior of an object, it's to look for ways to do that without changing the code of this class, of the class that is used for this object. Again, this will allow you this will allow the object to stay like a black box. You don't need to know anything about the internals. When you want to change its behavior, you do it from the outside. You just pull some switch or inject something else. Like this is an example, pretty simple example, where we have a game and something moves because of a random number from 1 to 6. And now the question comes like, how can we change this behavior to become hard-coded? Like we want to run a test, and we want to fix it to, or set it to be fixed to, say, 6 or something. All right? So now, what could we do? We could extend this class. We could say, there's this method. It used to be private, but we just make it protected for this reason. And then we return a hard-coded value, right? So we just return 6. I would recommend you to look for something else. And maybe you are already in this room, like already thinking, no, please don't use this, don't extend the class. But simply think of some other way in which you could influence the behavior, basically by injecting something configurable from the outside. So this is basically a combination of open-closed principle and dependency inversion, where you just think of a dependency for this thing that you make a bit more abstract. So you could say that we're looking for a die, basically, a thing you roll and it gives you a number, right? This is a bit of a weird word in English, but yeah, that's how it's called. And then you can inject it now. This will give you all kinds of cool advantages, like you can compose this thing. You can even use the die in different places, different ways. And you can make the classes final, which is great. I'm not sure everybody agrees about that, but I think it's really great. And this is how you could have different implementations for the same die. You could say we have the random die, which gives us an actual number, and we have the fixed one, which we can provide even a value in as a constructor argument. And this is even more cool because now we can even change this thing again without touching the code. We don't have to change 6 to 4 or anything. We can just inject this thing. So that's where this rule comes from. Maybe you've heard it before, like composition over inheritance. Prefer a way of changing behavior of objects by maybe injecting something, or like calling a method, like maybe change it from the outside, instead of using inheritance, like extending the class to change its behavior. So this brings us to a nice list of behaviors that you could do as a developer. Like, well, that's a coincidence. It's just like your objects with state and behavior in this sense. There are things you can do to make your objects better, and this is just a small list. There's much more, of course, and I think we have discussed them all by now. You should definitely introduce more types, wrap the primitive values inside objects. Thank you. Be more strict about using these types. Don't allow nulls or falses well, basically mess up the whole system. Design objects in such a way that they accept valid data, that they cannot end up being in an invalid state or like an unconceivable state, that they will always be useful whenever you call them. They will never say, yeah, you did something wrong while instantiating me, or something like that. And then, yeah, use composition instead of inheritance to change the behavior of objects. What I find is if you apply all of this advice, all of these rules, you will end up with a system that almost clicks together. Because of all these objects and all these types, they can only be used in valid ways. So it's more like finding the right values for a method call, and it will just work. There will be no surprises left. And I think in that sense, it's very much like Lego indeed. So it clicks together, and you can even rearrange the pieces in such a way that you will end up with a very useful other system that still uses these elements. All right, so I actually am within the the available time. So there is room for questions. There's also room for feedback. There's also room for questions outside of this room if you want. I'm always available on Twitter and also by email. So if you want to ask more. This is the stuff that will also form the basis for my new book. There's nothing about it yet online, but I'm writing on it, and it will be available somewhere next year. So keep an eye on this place, and you will know when it's there. Okay, thank you. Thank you. Okay.
Est-ce qu'il y a des questions?
2.5 minutes for questions. Yep.
Hi, how do you deal with logging when you fail early and with context that can be useful when you log?
Mm-hmm. Yeah, so how do you deal with logging? Well, the idea is that logging, at least in most cases, is only needed at the top level. So when you throw an exception, I just let it bubble up all the way up to the highest, like beginning of the application, basically, where you could wrap the whole application, and this is the place where you can log, and you would log the whole stack trace because you want all that information, right?
And what if you need more data deep in the code to know what really failed and have it structured?
Yeah, well, I think in most cases logging is useful for like general errors and for some progress indication, like where in the process did we stop. First of all, I would suggest using more strict testing, of course, because that's always the advice. If you can test for all of the edge cases, you can deal with them while doing that. But say it's like an import process, for example, where you want to log somewhere deep in the code. Just like inject the logger. It's perfectly fine. There's nothing wrong about that. Yep. Okay.
Une dernière question.
Hi. Do you have a strategy to deal with validation to make sure that the objects are correct without having exceptions?
So there's, like in the way that I'm explaining it, there's no room for validation without throwing exceptions. So whenever something calls a method or creates an object, you really throw exceptions just to prevent that anything else keeps going on like without you approving of it. Still, there is sometimes the need, of course, in particular when you're interacting with users, to tell the user that they are providing something that's in the wrong format or something. I usually use a separate object for that, which is more free in this sense. So there's the object that protects its state very rigorously, and an object that's just allowing data to be entered into it. This is known as a data transfer object, DTO, very simple data structure, and you can validate this object. So it will be a bit different maybe than you were thinking about, but yeah, this is the way you can divide the two.
Thank you.
Okay? Yep.
Thank you very much, Matthias.
Thank you.